I've been developing software for iOS for close to 9 years. So it may sound strange coming from me, but your app should probably have been a website. In this video, I'll explain why. Come to think of it, the entire market of native apps emerged as a stopgap, simply because mobile browsers weren't powerful enough in the late aughts and early 2010s. Of course, apps have since grown to be much more than simple website replacements. But the web hasn't stood still either. So in this episode, I'll guide you through the current state of web apps, specifically as an alternative to building something native. I'll show you what's possible to build and where native apps still have an edge. I'll also showcase my own pet project. It used to be a fully native UIKit app, but later it was rebuilt as a PWA. While it's in no way perfect, I believe it offers a comparable user experience, but available on every platform at a fraction of the time and development effort. While the phrase about the ultimate cross-platform framework in my SwiftUI video was ironic, because no technology is truly ultimate, I'd say that progressive web apps are the closest thing to the idea of having one code base for everything. But before we see what web apps can do for you, let's take a look at the shady side of native software, and why these days some users just refuse to download anything. Let's say you want to grab some junk food. Perhaps because you'll need a lot of energy to fix whatever garbage code your AI agent spat out. You open the menu of your favorite junk supplier and realize that in this economy you can only afford a mini Mac, not the big one. But then you see a prominent banner advertising the chain's coupons. You click on it just to find out that coupons are only available in the native app. The site graciously sends you to the App Store and you start the download. A minute passes, then another one. Then you notice that the app is a whopping 400 megabytes in size. 400 megabytes to get coupons. Okay, once the app is installed, it also requires you to register and click a confirmation link in an email. That link takes you to the browser and then redirects you back into the app. By that point, it has already fingerprinted your device and may also have requested your precise location. If you've already lost appetite, you're not alone. What could have been a seamless 1-minute experience, even with the login prompt, has actually cost you 15 minutes, multiple round trips to different apps, and half a gigabyte of your data plan. And this is the current reality in so many scenarios. Whenever you want to do something as simple as checking weather or train schedule, you're nearly guaranteed to see prompts to install a native app. Your ISP has one, your grocery store has one, and even your local coffee shop has one too. They tell you it's because they care about your comfort, but what they actually care about is their own bottom line. Native apps have turned into a very efficient surveillance vehicle a long time ago. There's not a single reason why a store loyalty card can't be saved in the built-in wallet app. It's typically got a single immutable payload, like your customer ID. So forcing you to install a native app and then open it every time you want to buy something has zero justification. At least for you. For the store itself, it provides valuable insights into your lifestyle, habits, and consumer behavior. Everything from your phone model to your precise physical location is collected, used, and often resold to data brokers. The user experience itself is often very far from perfect too. But even if you disregard all that, what you're left with is a herd of one-trick ponies. They occupy device storage. They waste bandwidth for installation and even more bandwidth for constant updates. But most importantly, they don't provide any meaningful ongoing functionality. They really could have just been websites. Okay, that's already grim enough for regular users. But what about developers? Surely they're the ones who benefit from all this native ecosystem. Are they? Many engineers I know really enjoy working with the native stack to build apps for iOS and macOS. But the native stack usually refers to the classic frameworks like AppKit and UIKit. Because when those engineers speak about SwiftUI, they use words I wouldn't dare repeat here. I wouldn't also repeat myself and cover SwiftUI's flaws and details, because there's a separate video about them. I'll just summarize that nearly every promise of SwiftUI turned out broken, just like the UIs it produces. So the question comes down to this. If imperfect UX no longer shocks or surprises anyone, can you at least improve your own developer experience and save on the cost of development at the same time? My answer is a resounding yes. What specific alternative you choose is a matter of preference. Some cross-platform frameworks specialize in mimicking the native UI, while others pursue brand consistency across all platforms. I considered a few options, like KMP, which I previously worked with, and React Native and Flutter, both of which I barely touched. Eventually though, I decided that they still require too much maintenance, at least for my small pet project. I wanted to have a proper web version for it anyway, so its availability is not limited to iOS devices. So at that point I thought, what if I start with a responsive web version first, and then see how I can improve it going forward? While my initial plan was to have just the website, I already had a native app used by a couple hundred people regularly, and I knew that migrating them elsewhere wouldn't be easy. Instead, I decided to try and wrap the website in a native shell. Importantly, I wanted to avoid using any support frameworks like Capacitor or Cordova, simply to minimize the amount of native code I'd have to maintain. And after running the project like this for close to a year, I can say that it's a totally viable option for the majority of use cases. But before we have a look at those, as well as the scenarios where you wouldn't want to use it, let me introduce you to the actual project. This is my app. It's called Space Photos. It shows images of the space fetched from NASA's Astronomy Picture of the Day service. You don't have to tell me it's got near zero business value, I know. For over 8 years, I just used the app as a playground to try out new frameworks and technologies. There's 100 alternatives with the exact same concept, my competitors. It's got 3 things that set it apart from NASA's version, and frankly most alternatives: design, performance, and a few extra features. My version adapts to screens of all sizes really well. It is blazing fast, almost as if the data was already prefetched on the device. And it lets you build a collection of your favorite space photos, stored locally and persistently. Again, I'm highlighting these areas not because the concept itself is somehow unique or revolutionary, it's totally not, but because these things require specific capabilities of the underlying stack. Let me walk you through them. The web is perhaps the OG framework for responsive layouts. With very modest effort on your side, they adapt fluidly to whatever surface you are using them on, from a phone display to a giant monitor to a printed sheet, if for some reason you would want to print an app screen. On the other hand, why not? Maybe someone would like to keep space photo printouts in a binder. In the most basic form, you use media queries and breakpoints to customize the UI based on screen width, height, or other properties. For instance, my app shows the tab bar on the bottom on small devices, but moves it to the top on tablets and computer monitors. There is no notion of distinct device families or UI idioms, though the latter no longer exists on iOS too. You can watch this video to learn more. And when there's a new device form factor, like foldables or whatever, websites adjust to it straight away. Support for different input methods comes out of the box just as well. For instance, the Spotlight carousel in my app works great with touch. But it also works with the trackpad just the way you'd expect from a native Mac app. And it works with the standard mouse wheel. And all this, plus the snap and place behavior, took me about 20 lines of code, mostly for snapping. This is possible because modern rendering engines are really powerful and truly versatile. They're not the engines of 2007 anymore, and they haven't been for a long time. So, the web absolutely checks the box on the visual part. It lets you build fully responsive layouts, which is a responsible thing to do to serve everyone. Now, what about performance? There's 2 aspects to consider when we talk about performance: the speed of data loading and the actual local rendering and interaction. While this wouldn't work for every app, mine is fully pre-rendered at build time, then it's just deployed statically. When a screen loads, it shows everything at once, without any extra fetching. However, it also supports client-side navigation, so when you go to another screen, only the actual data is loaded, while the page layout gets reused. It really is the best of both worlds. But in the context of comparing PWAs to native apps, rendering performance is definitely the key aspect. I'll be honest with you, browser engines would almost certainly lose to highly optimized UIKit code, but so would SwiftUI. However, if you had the resources to develop fully native, highly optimized UIKit apps, you wouldn't be looking into alternatives. So let's compare apples to apples. I mean, compare Apple's WebKit to Apple's SwiftUI. Both come with an abstraction layer you can't easily bypass. In one case, it's the rendering engine and the JIT compiler for client JavaScript code. In the other, it's the mind-boggling logic of diffing, state tracking, and view re-rendering. SwiftUI uses the main thread for all UI operations. If you load it with heavy tasks like data fetching or image decoding, you'll get degraded performance immediately. Drop frames, jittery scrolling, and all the other familiar things. WebKit and most modern browsers use a separate thread to handle user gestures, so scrolling stays buttery smooth nearly always. At the same time, the rendering engine knows virtually nothing about the structure of the page, so basically it has to rasterize it from scratch. It does use optimization techniques like tiling, which is similar to how UIKit's table and collection views only render the visible part of the list. However, because web pages don't have reusable cells in the same sense as UIKit, optimization opportunities are quite limited here. And when the rendering subsystem can't keep up with scrolling, you sometimes get empty tiles like this. Let's wrap up this segment with a head-to-head comparison of WebKit and SwiftUI. I'll use the same image gallery I demoed in the last video. The SwiftUI version has only 100 images, and it exhibits dropped frames on an older iPhone. The PWA has 120 images at the start, and it works perfectly on the same old iPhone. I've added 2 more pages, so now there's about 360 thumbnails, but I don't see any issues yet. Tiling artifacts start to appear only when I quickly scroll the page, while it has about 600 images. And remember, these are real separate images, because the cells in the grid are not reused. I don't know what SwiftUI is doing to deliver its embarrassing level of performance, because SwiftUI is still a black box, but the results are worlds apart. Of course, performance alone is not enough if the overall user experience feels alien. Yes, like those iPad apps on the Mac. So, what can web apps offer here, specifically on iOS? I'll be honest, it's complicated. On one hand, Apple has an incentive to keep developers within the App Store's walled garden with its fees and app review gatekeeping. This is why Apple is often late to implement web standards, and many of them don't work in WebKit at all. On the other hand, if WebKit gets too limited, Mac users will abandon Safari and switch to a different browser. A good illustration is push notifications on websites. The standard itself exists for over a decade. In fact, Safari was the first mainstream browser to support them back in Mavericks. But for all this time, Apple had refused to support push notifications on iOS until 2023. It was citing concerns about user experience and battery life, as if native push notifications were somehow different. Web push support was finally added to iOS in version 16.4, but only for websites pinned to the home screen. Why Apple couldn't use the same approach only 5 or 10 years earlier is a rhetorical question. However, only a year later, in 2024, Apple tried to kill pinned websites completely, instead turning them into plain shortcuts that open in the browser. This was widely believed to be a retaliation against the DMA in Europe, and after the backlash that followed, Apple backed off. As of today, PWAs pinned to the home screen can fill the entire display, present native controls like share sheets and date pickers, and receive push notifications. On modern iOS versions, all websites, even those in the regular browser, support light and dark modes, keyframed animations, and even state transitions with element matching. It is similar to the new zoom transition in UIKit and SwiftUI. Thanks to the web standards Apple did implement, websites can also store data persistently on the device, run tests in the background, and even work completely offline. There's a number of standards Apple hasn't implemented though. One of them is the vibration API. Except for a small number of input elements, web apps mostly don't have haptic feedback. But that doesn't mean your hands are tied, not at all. In fact, you can call virtually any native API from a web app, if you wrap it in a native shell. I'm not talking about frameworks like Capacitor. My Playground project is a plain web view in a lightweight UIKit wrapper. I'll save a detailed walkthrough for another time, but in short, this architecture allowed my app to provide real haptic feedback, migrate core data records to IndexedDB, and offer shortcuts on the home screen. While implementing all this requires using an Objective-C protocol, you can optimize the setup to be more Swifty, with async functions and statically typed codable payloads. In a future video, I'll focus on this part, so if you're interested, don't forget to subscribe. It seems that the technology is already there to enable fast, powerful, and capable websites, ones that can rival native apps. Let's see when they can actually be the better choice, and when native code still has an edge. Again, we're not talking about super polished products. In those cases, AppKit or UIKit is pretty much your only viable option, as we established in the SwiftUI video. I would say that from the user's perspective, about 90% of all use cases work completely fine as progressive web apps. First and foremost, that includes the entire category of content readers. social media apps, video players, those coupon apps I mentioned earlier, and so on. Surprisingly, graphics-heavy stuff can also work on the web fairly well, thanks to WebGL, WebGPU, and specialized libraries like Three.js. You can build real 3D games running in the browser, and I recommend you check out some of the existing projects. And if you're a hater of JavaScript, thanks to WebAssembly, you can write high-performance business logic in languages like C, Rust, and yes, Swift. One area where native code remains unrivaled is deep hardware integration. As you saw, push notifications work on the web easily. If the user needs to take or upload a photo, web apps support this too by delegating the task to the operating system. However, when you need precise camera control, complex real-time processing, or raw capture, then the web would probably feel too limited. You can still build a hybrid app and leverage its native shell though. The same is true for apps that need to have consistent access to the user's photo gallery, contacts, or calendars. But knowing how apps tend to abuse it, I personally wouldn't grant such access anyway. You can watch more in this video comparing the privacy features of iOS and Graphene OS. In summary, I'd say starting in the web browser and only adding native code when absolutely necessary is a totally viable launch strategy. It lets you test products' hypotheses with minimum time and effort, and check them on all platforms at once. But now let's go back to what we started with, the developer experience. Of course, many things would depend on the specific front-end framework that you choose for a project. And if you paid attention, I never mentioned what framework my app is built with. That's because it doesn't matter. You really do have to choose the best tool for your job, and what works for me may not work for you. So let's focus on the core experience of building web apps. With a pure website, you get responsive UI layouts with animations, support for multiple input modes, persistent storage, and impressive performance. If the same website is pinned to the home screen, you also unlock push notifications and extended background execution. And if you wrap this very website in a native shell, you can do even more than that. Basically, every native API becomes available to you. Nearly all front-end frameworks support instant previews and hot reloading. And unlike SwiftUI, they don't crash just because the type checker has run out of time. In a future video, I'll have a deep dive into my app's hybrid architecture. If you're interested, subscribe to the channel. But again, architecting a native wrapper is not strictly necessary, because all the key milestones of high-quality software can be achieved pretty much everywhere with a single codebase. In the SwiftUI video, I said I had rebuilt my app using the ultimate cross-platform framework. I used this exact phrasing, and that was important to be precise. Is the web the ultimate framework, period? That's debatable, and many would rightly reject this sort of generalization. Native stacks often have superior developer experience, performance, or stability. In my opinion, SwiftUI is not one of them, because it's not the best tool for anything, but we've talked about that already. On the other hand, is the web the ultimate cross-platform framework? In other words, the stack that offers ultimate cross-platform support? Unequivocally, yes. Websites objectively run on the greatest number of platforms, either completely unchanged or with very minimal modifications. In future videos, I'll have a detailed look at what those modifications are and what else I had to account for to make my app feel better than a regular website. But just before we wrap up, I'll add this intermission. You've watched the regular version of this video. There's an extended cut available to channel members. It includes a longer introduction, more detailed examples, and a couple extra things. However, this public version is in no way compromised compared to it. It's just that YouTube constantly makes you fight for viewer attention, especially in the intro section, so I had to trim down the video. In the director's cut, I get to include everything I originally planned for this video. If you want the most complete version, go check it out. That's it for today's Codebird episode. If you're interested in building PWAs, subscribe to the channel so you don't miss the next one. And if you're not interested in PWAs, this channel's got other topics covered too. I'll see you next time. Until then, make your apps fly.